10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond.
Liftoff of OSIRIS-REx, its 7-year mission to go to the asteroid Bennu and back.
Well, welcome and thanks for joining us. I'm Dwayne Brown with the Office of Communications, and welcome to another edition of Science Chat, where we talk about science. For the next 30 minutes, we are talking about 2 upcoming out-of-this-world encounters, unprecedented NASA planetary missions that could answer questions about our solar system and beyond, and perhaps where we even come from. I'm joined by scientists from each of these incredible missions: Hal Weaver with New Horizons and Melissa Morris from OSIRIS-REx. I get to chat with them, but you get to send in your questions via email or on social media with the hashtag AskNASA. So let's get started. Let's take a look at missions going to small worlds, returning big discoveries.
Hey, welcome to Science in Seconds.
We're here to tell you 5 reasons why NASA is sending spacecraft to study Kuiper Belt object Ultima Thule and asteroid Bennu.
First, studying the compositions, orbits, and physical properties of these small worlds can help us understand not only the objects themselves, but also the origin of our Sun, the Earth, and our Moon.
Second, understanding the distributions of organic molecules, water, and other volatile compounds can tell us how these essential materials for life formed in space.
Third, small worlds provide a window into physical processes that continue to shape our solar system even today.
Fourth, determining the orbits and physical characteristics of objects that could potentially impact Earth is critical for understanding the consequences.
And finally, mineral resources may be available in the small worlds for use by human explorers as we venture deeper into our solar system.
We are so excited to see what big discoveries they hold.
Wow. Well, let's get started. Hal Weaver from New Horizons, Melissa Morris. Oh my goodness. The public is excited about this. Let's start with you, Hal. New Horizons. We all remember Pluto. What's up next? You guys are like doing an encore here. What's going on?
Yeah, so it was just 3.5 years ago that the NASA's New Horizons spacecraft flew about 7,500 miles above the surface of Pluto and returned these incredible pictures with turning Pluto from a pixelated blob into this incredible, wonderful world with complexity and diversity that you would never have known unless you sent a spacecraft there. Well, that was our first object that we passed in the Kuiper Belt, this 3rd zone of the solar system, newly discovered since the early 1990s. And now we're about ready to fly through by another Kuiper Belt object, a completely different kind, Ultima Thule, on New Year's Day.
Yeah, New Year's Day. We're going to talk more about that one. Okay, so Melissa, oh my goodness, OSIRIS-REx. You know, this mission has some pretty incredible things that are coming up fairly closely. Let's talk about that.
Well, the next thing that's coming up, we're in the approach phase right now, and so we will transition from the approach phase to arrival. We will arrive at the asteroid Bennu on December 3rd and begin what we call asteroid operations. We'll do a few flybys, 3 at the North Pole, 1 at the equator, 1 at the South Pole, kind of take a lay of the land, so to speak, and begin 2 years of in-depth study of the asteroid so that we can gain as much information as possible and find a safe spot to get that sample collection to bring back to Earth for study.
Wow. And you know what's another cool thing about this, and we're getting to the people thing, because it's about the people, right? You know, NASA takes diversity very seriously. And I mean, you guys, I think we've got some serious woman power on this mission, right?
Absolutely. I think this may be one of the most diverse missions that I've seen. I'm the deputy program scientist. The deputy principal investigator at University of Arizona is female. And I've lost count of the number of scientists and engineers, great female contribution to this mission. And we have, of course, diversity in other ways too. So very happy with that.
Wow. Now, as the deputy program scientist, what does that entail? If, you know, we've got folks here that's, wow, that's got to be a pretty cool position. What do you do there?
Well, I can tell you it's a lot of fun. I get to participate in this great mission. There are 3 aspects to the mission itself. There's the project, which is at headquartered out of, not at headquarters, but at Goddard Space Flight Center. It's a PI-led mission out of the University of Arizona, and of course headquarters, you know, oversees it all. I like to think of myself as the deputy program scientist as kind of the liaison between especially the PI and the science center, the science team, and headquarters, and of course the program scientist, Jeff Grossman.
Right. And for Hal, with the project scientist, what role does that play in this incredible mission?
Yeah, so this project scientist really is the principal interface between the engineering team and the science team. So as the mission is being developed and all the instruments are being designed, we have all these specifications that the engineers try to follow, but you find along the development path that there are lots of decisions to be made, but you have to take into account what the objectives, the scientific objectives of the mission are, as well as the engineering aspects, and I'm in the middle of all of that. It's a lot of fun.
And we're going to have a okay, before we take questions, just one thing that these cameras, I'm sorry, the missions have cameras, correct?
Oh, absolutely.
Let's talk about that, and then we're going to take a social question.
Yeah, so all of the NASA robotic spacecraft exploring the solar system always take their eyes with them, you know, cameras. And New Horizons mission is the same way. We have an 8-inch telescope that provides the highest resolution of all the cameras on the New Horizons mission, but we also have a color camera, so we take both color and gray images, in fact, here's a model that you can
and
bring
actually,
up here.
this comes from South Africa.
South Africa.
It's handmade bead. I mean, this is pretty incredible.
Yeah, it's really cool.
So kudos to the designer and creator of this.
And this is our 8-inch telescope, our Eagle Eyes, the ones that give us the highest resolution, the LORRI instrument.
Was that the camera that took the incredible Pluto flybys? Right?
Yes, yes.
Wow.
But then we also had on this side over here the Ralph instrument, which has a color camera and a near-infrared spectral imager. And all of these are pointing, looking off in the same direction.
Wow. So we're going to get to Melissa. You guys have a lot of cameras on yours, but let's get to the audience here. We're getting inundated with questions here. So let's go to social media, and we have a question from social media that's coming up soon. But while we wait for that, okay, here we go. All right. From Julia Lewis on Facebook asks, is the distribution of dust density, this is one scientist, must be a scientist here, Julie, from the icy bodies in the Kuiper Belt affected by Planet 9's gravity? How does the student dust counter collect data, and what do you expect to learn from the dust? Got a 3-part there. Who wants to?
Well, so since this is where New Horizons is headed, right into the Kuiper Belt, Planet 9, by the way, is Pluto. I don't think that's what she meant.
Touche.
Yes,
I
yes,
like
yes.
that.
That's what we always like to say. And Pluto is definitely not affecting the dust density so much in the Kuiper Belt. This other planet X, we might refer to, which maybe some people have heard about, and I think that's what Julia is referring to. Yeah, it does have some effect on the bodies in the Kuiper Belt, assuming it is there. We don't really know that for sure. But we do have instruments that are going to be measuring the dust density along the spacecraft trajectory, the New Horizons spacecraft trajectory. And we're flying through the densest portion of the Kuiper Belt right now. And as we fly by Ultima Thule, that student dust counter is going to be counting dust particles all along the way.
Wow. So we're going to take a question from the media, but I want to go back to you, Melissa. We talked about the cameras. The public knows the incredible pictures New Horizons took of the Pluto flyby. You got some pretty cool cameras, and there's a picture you guys took of your target, right?
Absolutely. So OSIRIS-REx has a suite of cameras. Collectively, they're called OCAMs, and they're used for different purposes. Some are for navigation, some are for imaging, and some are actually imaging the sample arm when it reaches out to grab that sample. But we've gotten some close enough. We've gotten some fantastic images already, and there's a great one that you can find and see already up there for the public to view of a nice rotation of Bennu.
And go to nasa.gov to see that image. Okay, so let's get to questions, because I could talk to these guys all day long. From Kimberly, PBS, Kimberly Davis in Arizona. What makes OSIRIS-REx sample return capsule secure enough? Ooh, okay. Getting into that planetary protection type thing. Is it possible to lose some of the material collected on the way back?
These are fantastic questions. Now, the sample return capsule that will be used for OSIRIS-REx is proven technology. This is the same type of sample return capsule that was used for the Stardust mission when we went and collected samples from a comet. As far as losing some of the material, that would be so highly unlikely that because this is proven technology, we've used it before. I think you were hinting at a different question.
Oh, what would that be?
And that's keeping the samples safe or anything else?
Yeah, I think we don't want to bring back little green things or whatever. So but we take that seriously, right?
Right.
Yeah. So
absolutely. One of the things to consider when you're thinking of introducing any type of alien life form, which I think you're getting at, is that Bennu is an asteroid with no atmosphere in the harsh radiation of space. The likelihood of any life as we know it surviving those conditions is statistically so small that it's not a threat. In fact, the biggest threat, and the reason we want to make that sample return canister secure and collect it and curate the samples properly, is there's a much bigger chance that we're going to contaminate the sample with terrestrial contamination. So.
Wow. Okay, so let's take another look at these incredible missions again. Going to small worlds, returning big discoveries.
Ultima Thule is an object in the Kuiper Belt.
Bennu is an asteroid, and it's the destination of the OSIRIS-REx mission, which is an asteroid sample return mission.
Every star and every planet around that star has a Kuiper Belt, and New Horizons is the first going to our Kuiper Belt and exploring it. That's pretty fantastic. The Kuiper Belt is the edge of our very solar system. It's the part of the original disk that the sun and the planets formed out of that's at the very edge before you just get into the galaxy and the region between the stars. And at that very edge of the disk, there wasn't enough stuff to make giant planets and make big stars like our sun. There was just enough stuff to make small dwarf planets and snowballs.
An asteroid is one of the leftover building blocks of the solar system. And in some cases, they are simply just the pristine pieces that never formed into anything else. But in other cases, they're actually the remnants from large collisions as the planets formed and sometimes broke apart. And so we see a variety of different types of asteroids that look distinctly different from each other depending on how they formed. Bennu is different from a Kuiper Belt object in that it spent most of its life inside the inner solar system as opposed to the outer solar system. And that means that they likely formed under different conditions, very different temperatures, and also with different materials around them. So we think the Kuiper Belt objects are much more likely to be icy and have water ice, whereas an asteroid won't. And that's the primary difference between them, but we expect them both to be building blocks of the early solar system.
Ultima Thule is an object in the Kuiper Belt. It's a member of the group that we call in the Kuiper Belt the Cold Classicals. That's fancy astronomer speak for object that has formed in place and never been perturbed or moved around.
Bennu is likely part of what we call a collisional family, and that means that it originally came from a bigger asteroid that broke apart in a collision at some point in time. Now, this particular asteroid is very interesting to us because it's very dark. It reflects only 3% of the light that it's receiving from the sun, so we think that means it's covered in carbon and organics, which are the building blocks of life. And we'd like to understand how common those building blocks were in the early solar system.
Ultima Thule means in Latin for farthest land. If you think about it by analogy, New Horizons is going to the farthest part of our solar system, and it is very cold and dark and barren out there. Like any Kuiper Belt object, formed in the far reaches of our solar system. It formed where ice, water ice, is as hard and as strong as rock. It formed where other ice is even more volatile, like methane or carbon monoxide or nitrogen, can still be held and captured. So unlike an asteroid, which is actually just a piece of rock, and possibly a piece of rock that has melted and changed over with some alteration by some internal water, Ultima Thule never melted, never differentiated, never made a core, even like our planet Earth has a core. All that stuff is just as it came from the galaxy, we think, and is just a, if you will, a random loose snowball accreted material. So we'll see if that's really true.
And we're here at another edition of Science Chat here with Hal Weaver from New Horizons and Melissa Morris from OSIRIS-REx. Now, in that video, we were talking about aliens and planetary protection, but when they talk organics, is that living, or how do you explain organics when you may have organics?
So organic, and that's a misconception that's frequent, especially with the public, is that when you say organics, that you mean life. Organics just means complex carbon molecules. It's not something that's living. But you do find the precursors for life in meteorites that are similar to, that have the same spectral signature as Bennu. One of the reasons we're going is to kind of unlock that mystery of where some of these precursors for life may have come from.
Wow. Before we take a media question, when the scientists have got to be super excited that they're bringing material back, right? I mean, this is the first time ever, right, for a NASA spacecraft. This is the first or the largest sample returned since Apollo, and the first NASA mission to return samples from an asteroid. And so we're very excited to bring these samples back. And in fact, a good portion of those samples will be curated for future generations of scientists to use tools that we don't have and ask questions we don't even know to ask at this point. Wow. So we're excited. Wow. Okay, let's, we're going to go to media, but before that, we're going to take social media. David B. Flower. Hey there, David. Question, what are you looking forward to the most when your craft reaches their respective destination? Hal, let's start with you.
Okay, so Ultima Thule, we know very little about right now, but we think it's the most primitive object ever visited by a spacecraft. As you heard, because it's been out there 4 billion miles from the sun, 1 billion miles past Pluto's been kept in the coldest portion of the solar system for 4.6 billion years. That's preserved what the material was at the time of the formation of the solar system. It preserves a record of the physics and chemistry of what was going on. So we're essentially looking back in time, 4.6 billion years, when we look at Ultima Thule now. But we've never had a spacecraft go out into that region of space and pass by a body, so we have no idea what to expect. It's very mysterious. So it's the first time. And that's the excitement about exploration, right? This is the frontier of planetary science.
Well, I mean, these missions just have many firsts. And now let's go to OSIRIS-REx. What's
Oh, that's so hard to determine what is the thing I'm looking forward to the most. And I think everyone who's on the mission has, a little something different they're looking for. It's what it looks like. Is it what we expected? It would be cool if it wasn't, but we have a good idea of what it should be like. How many boulders are on the surface? Is there smooth terrain? Is there dust? You know, we have been in the process of doing dust plume searches and natural satellite searches. So is there anything unexpected? So there are too many things to mention.
Well, it sounds like libraries are going to be busy tossing out the old science books and trying to and stocking, restocking with new ones. Okay, let's go back to social media, talking about two incredible missions, visiting small worlds, bringing back big discoveries. Social media again, from Facebook. Why do you think asteroids Bennu and is that Ryugu? How do you pronounce that? And even Ryugu and even Neptune's moon Proteus are shaped like diamonds. Well, that's interesting.
So there is a really interesting shape. It's more pronounced with the Hayabusa 2 target. That's the Japanese mission to Ryugu, which I know I'm not saying as well as
I didn't say
could.
it right anyway. So for the folks who know that, you can send that in and tell us how to pronounce it, but you get the idea.
But you can see the shape. They're not spherical at all. They're close to becoming a sphere, but they are a little diamond shaped. And part of that is we think they're very loose aggregates. They're not solid through and through. And so as they rotate, you can actually basically spin things out and create almost that top shape.
Wow, and as we see this, I mean, this is Bennu, right?
This is Bennu.
What are we looking at? I mean, look at it. I mean, that thing is...
It's a rubble pile.
It's a pile of rocks. It's a pile of rocks that's just loosely held together, we believe. And one of the most exciting things that we've been noticing, if you compare this to the images of Ryugu, there is much more contrast in light areas and dark areas, and you know, we're in these bright areas, and we're so excited and curious to see why that is, why there's this contrast difference.
Now, that looks like the spacecraft is like right next to it, but it's pretty still far away, right?
It is. I mean, it's closer than you think, though. We've gone from Earth, you know, and way out there to this near-Earth asteroid. To we are, I don't know the exact date today because we're moving so quickly now towards it. But, you know, last week we were about the distance from here to San Diego, so.
And these spacecraft are moving pretty fast, right? How fast is yours? Let's see
Well,
which one is-
ours now, I can tell you already which one's faster, but ours right now is going very slowly because we had two braking burns just recently to slow it down, because unlike Ultima Thule, which will do a flyby and really can't slow down, which I'm sure Hal will tell you all about, we need to slow down because we're actually going to do orbital insertion and study that asteroid up close and personal for 2 years.
Okay, well, let's take some media questions, and then we'll talk about speed later in the show. So from Kodo News, what do you think of the collaboration with the Japanese asteroid mission Hayabusa? I think you talked about that. Do you have any specific plans to cooperate with the Hayabusa 2 team? That's an excellent question. They've done a fantastic job with that mission.
It's amazing. There's so much international cooperation which goes both ways between the OSIRIS-REx mission and Hayabusa 2. We actually exchange team members. There will be an exchange of samples. Part of the sample that Hayabusa 2 will collect from Ryugu will be given to the science team of OSIRIS-REx, and reciprocate. The OSIRIS-REx will reciprocate with, I think it's 10% of Hayabusa 2 samples come to OSIRIS-REx and 0.5% go to the Japanese Association. And it's going to be fascinating to compare and contrast these two different missions and the results. They're sampling 3 different sites that look diverse and different. We're trying to get more stuff from one sample site, and so they're very complementary and the great spirit of cooperation.
Fantastic, and again, congratulations to the Hayabusa team. Just incredible work.
Absolutely.
So let's take another look at the spacecraft and the team behind these guys.
We are flying into the unknown. This is really discovery.
We navigators are here on Earth, and we're trying to fly a spacecraft remotely.
And we will get to see Ultima Thule for the first time.
We're going to learn so much from the Bennu about the formation of our solar system.
For sure, it's going to surprise us.
The primary difference between New Horizon and OSIRIS-REx approach to their targets is the velocity.
Our flyby speed when we fly by Ultima Thule will be about 32,000 miles per hour.
So there's no slowing down. OSIRIS-REx, on the other hand, was designed to rendezvous with Bennu, to match Bennu's orbit. The first two approach maneuvers for OSIRIS-REx slow the velocity down from 1,100 miles per hour to less than 1 mile per hour.
New Horizons is a flyby mission. We have one chance to get it right.
Flying a spacecraft in practice is really not like flying a plane or playing a video game.
You have to plan many, many weeks in advance.
The principles of navigation still apply. You have information around you that tells you where you are, and you do corrections to get on the course to where you want to be.
For a critical flyby, like Ultima Thule, we actually started planning the set of commands to the spacecraft about 1.5 years ago.
In space, the environment is a lot different. There's no GPS.
New Horizons is going to be about 4 billion miles from Earth. It takes us 6 hours and 8 minutes to get a command sent from Earth to the spacecraft.
It takes over 6 minutes for the signal to leave OSIRIS-REx and reach Earth traveling at the speed of light.
What we do is we load commands to memory, and they execute out of spacecraft memory as the onboard clock ticks down.
To get to Bennu's doorstep, we need to use a technique called optical navigation, where we command the spacecraft to take pictures, and those pictures give us information about where the spacecraft was relative to Bennu when they were taken. We use that to determine the course that we're on and compare that to the course that we want to be on. We do the maneuver to get us back on track and at Bennu's doorstep.
I didn't have any preconceived notion of what we might see at Pluto. It has been simply amazing. I mean, Pluto has it all. It's volcanoes, it's ice fields, it's mountains, it's atmosphere, it's haze. Pluto is just an amazing place. And Ultima Thule, we may find out that it's got the same sort of things going on.
What's really groundbreaking about the navigation on OSIRIS-REx is the size of Bennu. Bennu is the smallest object to ever be orbited by a spacecraft. Because the gravity is so low, we can effectively maneuver around the whole entire asteroid without using much fuel. And it allows us to map the entire surface in a matter of 2 weeks.
I grew up in the 60s and was continually watching the Mercury, Gemini, Apollo astronauts on TV. I really wanted to have an exciting life like those astronauts were having. I knew that I wanted to do something where I could make a difference, and every day was different.
Copy that. Looks like we have a good theater.
It was the Hubble Deep Field image that came out when I was in high school, the one with the thousands of galaxies in one frame, that really inspired me to be able to contribute in some way to expanding our knowledge of the universe.
Science is an amazing field. Any kind of science. There's always more to learn. There's always something more to discover.
What I love about navigation is it's kind of where engineering and science are combined. It's really where you do the hard engineering to achieve the science objectives of a mission.
Wow, so Hal and Melissa, we're kind of, 30 minutes is way too short to talk about these two missions, but you know, with time limit, really quick, it's got to be amazing that you guys, the farthest planetary encounter ever, is that right?
Oh, absolutely. The New Horizons spacecraft was the fastest ever to leave the Earth. It's been blazing a path through the solar system. It's moving about 10 miles per second. And this object, Ultima Thule, is roughly only 20 miles across. And so it's white knuckle time as we fly by, try to cram as much as we possibly can, squeeze as much science out as possible to look back 4.6 billion years at this primitive body, and then we're off continuing deeper into the Kuiper Belt.
I was going to ask you, what happens to the spacecraft? It just keeps going.
It keeps going. We have some other planned observations of Kuiper Belt objects, but not, this is the highlight of the Kuiper extended mission for the New Horizons.
And OSIRIS-REx, when it finishes, what does the spacecraft do? I know you've got return the samples, but what happens to the spacecraft?
Right, and as far as I know, I do know what would happen if it would be unsafe to release the sample if we had a problem. It'll just go in orbit around the sun, and so the spacecraft, once it releases its sample back to us, bringing it back home, then it will just continue on.
Well, thank you all for joining us. Hal, incredible. Melissa, incredible. Doubleheader, a lot of excitement, bringing you two incredible missions going to small worlds and returning big discoveries. New Horizons, OSIRIS-REx, all information and updates, and look out for that. A lot coming towards you. www.nasa.gov, and continue to send your questions in to #AskNASA. Thanks for joining us. Good luck to both teams. Science never sleeps.